rocks.
Okay.
Then you can then place them with the little wand in the bonsai pot. And when you do, it will start to populate the other big island, which is a perfect copy of the small island, and start to fill it with life, with rocks, with seaweed, whatever it is. And so that is the way to interact with the world. You might even be able to craft out new tools that you can attach to your effector device to add to your ability to interact with the world or to move through the world. And so with that, we also talked a bit about representation and drive and how machines might engage with an unknown problem space upon first deployment. So now, if you want to play as well, we're going to go for another 5 to 7 minutes now. If you now with that information in mind, you can jump back in if you want and begin to terraform to your heart's content.
Okay, cool.
And if anyone has any questions, just pop back on here and talk. Don't worry about spoiling it for your colleagues. I'm sure we'll all everyone will appreciate pro tips. I'm going to quickly get a glass of water and then I will return. I apologize, Mike.
All right.
Dry. Hope everyone's having success now at picking things up and interacting with them, and maybe even hitting them with hammers. I will note that again, that depending on the number and size of hammer blows that you apply to the items on the anvil, they might turn into different things. So you might actually have the ability to control in one way or another what it is that you're creating. Block sizes might also matter. You might be creating different things with different block sizes. As a blacksmith, I appreciate this very much. So your materials and the way you interact with the materials do change the final product, and this game is no different. And while we're moving forward, Nimit, we did introductions earlier, so I didn't get a chance to know what program are you in, and what brings you to the course. What have you learned about AI so far?
Oh yeah, I'm in medicine.
Okay.
Yeah, I've been learning a lot in this course. I'd say this is the most fun session so far.
Note to self: bring video games in hand every time I ever do. No, good to know. Cool. I just want to say, like I told the others as well, but the learning, like I like specifying learning objectives. It's not all just fun and games. We're doing it for a reason. Like I know in the course, everyone's talked a lot about the implications of AI and to really consider those well and to think about them clearly. I like to walk through the precursors or hallmarks to intelligence and how machine intelligence might express itself. So our goals for today are think about like, how do machines interact with the environments they're placed within, like intelligent machines? How might they learn to perceive and then to understand the patterns within and to act upon the environments they're placed in, and when and how might that learning occur, when and how might the change in their internal structures occur, and how might they be motivated in those environments. So that's why we're doing this fun exercise, why we're actually playing games in class, is that we're trying to really understand how a machine might engage. And so when I threw everyone else in, I said, hey, here's like a web link, go play a game, here's your controls, and that's it. We were then just starting to talk about, well, why, what were people doing when they were first put in this unknown environment? Like, they were taking actions, they were figuring out what their keys were doing, they were trying to figure out what they could control and what they couldn't. They're trying to localize within the environment and understand where they could and couldn't move. So we're sort of stepping through what it's like to be a machine that walks out into the unknown and is asked to interact with its environment. So that's the why. That's the learning objective, is to really understand some of the hallmarks of intelligence, how they express in deployment.
Okay, yeah, that makes a lot more sense now what we're doing.
There's method in my madness. I haven't tried this before though, so it might be a roaring failure. We'll find out. We can do forensic analysis on the recording to see if this actually did a good job or not. Okay, how's everyone doing? Is everyone okay to, like, do you want to keep going for another minute or two? Everyone want to come back and talk about it? What's up? This was good. All right. It's good. It's good. Okay. If you want to come back, just pop back. If you want, just pop back on camera if you're using camera, and when you're ready to chat more, and I will, or just give a, I think, yeah, no, you've all signaled good. Okay. Great. Okay. So what was different that time? Kim, I'm gonna let you go first since you're on camera. But what was, so when you interacted with the world this time around, what did you do differently?
Well, having the idea that there is a model and you can, that model is the same as the larger landscape, that was really exciting. And yeah, I didn't really do much with it, but and the full screen images are very beautiful. So I did some screen captures, which we may need, What were they doing? What were they doing on the 17th? We have no record. Yeah, we need a record. So yeah.
Fair enough.
That's what I was doing.
Yeah. Cool. Well, maybe Mythbot, maybe I'll jump to you now since I saw you pop back on camera. So what was different this time? Like, you had more knowledge about the structure of the world. Did your goals change? Did your interpretation of your affordances or the actions you could take in the world change? What was different this time around?
Yeah, so I think for me, like, it was definitely different because I had like a lot more structure, I think, going into it. So like I picked up the cube, and then like I was trying to find which tongs fit like which cube size, and then like carried that over, and there was like a process to put it like into like the hot like pot, and then it was like a whole process to figure out like which hammer worked properly with it, and then take it back like to the anvil. But I didn't get too much into like forming the actual world, but like I think I got like the process down, which was a lot better. So like I was just trying to at that point like find as many cubes as I could that would like fit into like the hot pot. But yeah, I think my goal changed a little.
Mm-hmm. And did you, so I'll ask as well.
Yeah.
So when you were interacting with objects, there were actually some substantive, hopefully some substantive color changes in terms of the device you were using. It might have changed color occasionally. Was that like, were you trying to form patterns? Did you try to grok what those color changes meant?
Yeah, so I think that like in the beginning, I didn't really realize that it changed from blue. Like I was just trying to pick up everything when like the like arm was blue, but then later like I figured out that if it means green, it means that that object fits with the size of like the tool that you're using, which was awesome. And then once you have it, it turns purple, which is cool. And then you know that like you have it with you, so you can like move to the next station. And then one thing I had to like make sure of was like not dropping the object like in the table. I had to like put it on the table because otherwise it disappears. So I like made sure to put it on the table, but otherwise, yeah, like the color changes help for sure.
Yeah. There's the drop through. If you're partly clipping through the anvil, then yeah, it'll drop into the anvil, and then you have trouble finding it. You have to dive in. Okay, cool. Very cool. Okay, that is not intended behavior. That's just like a no collision checking on the anvil when you're holding the object. So I apologize. It should pop back out again for you. I'll fix that. Okay, awesome. So that is different. let's say, Riha, how about you? What did you find this time? What was different? What changed in your interpretation of the data stream?
I think my approach was like more focused this time because like the first time I was just like wandering around and exploring, but now I felt like I had a bit of like a purpose and a goal to achieve, and I had like more structure going in, as Mispa said. So yeah, I like learned how to pick up the blocks and stuff. Earlier when I was trying to pick up the blocks, I was holding space, but then I realized you have to just click it once and that's how you pick them up. So that's something that I improved on this time. And then with the color changes, I kind of use them as a like hint that I'm doing something that's like kind of right. 'Cause I'm like, oh, if this is changing color, then maybe this is what's supposed to happen and this is what I'm supposed to do. So I kind of use that as like a bit of encouragement. I'm like, oh, this is probably what I'm supposed to be doing with like this particular object or whatever. So yeah.
Very cool. Did you manage to make any trees or rocks in the end?
I didn't, but I'm like halfway through making them. So I think after class, I'm going to work towards making some trees and rocks.
Okay. I didn't give you enough time. I apologize. I wanted to make sure we had time to talk about it though, and not just play games all day. So but I think this still achieved the goals. JC, how about you? Did you, what did you find? What was different? What was the same?
I mean, it was the same because I had already been putting the things in the hot pot area, but then knowing that you had to like hammer them on the anvil was really helpful. And I made I think I made a rock and then I put it in the little island thing and it came with the little light beam under it, but I wasn't sure. Like I looked around to see if it was in the area and like I didn't see it. I don't know if that was what it was supposed to do, but yeah, it was definitely more focused and I was happy that I like knew what the goal was.
Did you after you placed it in the pot, did you fly over to the other island?
Oh no, I didn't.
Yeah. So anyway, cool. This is very good. This is all okay. Great. We have lots to talk about after we're done this. Nimno, how about you? Did you end up trying to play the game a little, or just?
No, I didn't. I think that my system crashed and I restarted and all that boring stuff. Yeah.
Cool. How about you, Nimno? Did you?
Yeah, I know I've been struggling with it because after hearing, I guess, like what you're supposed to do, it's easier, but my rock got placed like halfway up, like it's not even on the land thing, so there's like a blue line under it, so having a bit of trouble. Yeah.
Did you fly over to the island?
It's like a MacBook, and like I can already, it's like about to take off. There's so much air running, like this game is running really slowly for me, so I couldn't.
Okay, I apologize. It is not optimized. This is the one downside of fly by the seat of your pants deployment is I didn't do much optimization, so it does actually take a lot of crunch. So I apologize if you're having slowdowns. It's my fault in part for putting all the animals in and leaving that into the deployment. But okay, so what you would have found is that in fact, as you place the objects in the pot, they'll start to populate the island. You'll see like mushrooms and trees and flowers and other things that start to pop up in the place that you put it. So because they're perfect analogs of each other, where you place it will start to spawn a whole bunch of different objects. If you place it near the water, it might even turn into things underwater. Okay, but it's not that's if you want, I'm not going to take this down. So if you want to play with this later, by all means, if you find something that really breaks for you, just shoot me a line and I can try to fix it. But this is great. So now imagine that you were to take a machine, let's just say an arbitrary machine capable of learning. What would that, now we're going to really start to break down those core elements of this interaction problem. From the very get-go, let's say we have this machine, we hope it to engage with this environment. What is a precursor for it to engage with that environment? What does it need to begin to even start to interact with the environment in the way that you did? Any thoughts?
This is just a guess, but maybe just things that can be like manipulated. Like you need to have something that can potentially change if you do something to it, rather than it being like a video that like doesn't change and you can just like watch what's happening. So yeah, I guess you need variables of some kind.
And this is a really interesting point because you do need to like in some way there's actions that are specified. Like the machine itself would need to, in some way, have a way to act upon the world. If it had no way of acting upon the world, that doesn't mean it might not be doing something important. It could be a prediction machine. But if we truly want a machine to engage in a way with the world to affect change in that world, then you're right. Like this is a core part of this data stream. The interaction stream is the actions that flow from the agent, from the machine to the world. In your cases, that like you interacted via the keyboard, that was your interface, but you were able to take actions upon the world. So those have to be defined. There had to be something spelled out for the agent. Cool. Yes, absolutely. So actions are important for decision making. There has to be some way to act upon the world. Any designer of a learning machine or a machine that is going to engage with the world is in some way creating those actions, even if it's someone like a human user looking at the output of a machine and then taking actions upon it. Cool. What else would the machine need to begin to engage with this world? I'll prime it a little bit to see if we can move from there. How did you know anything about the world? As players, as human players.
Well, for me, it was from the instructions and from everything you said.
Okay, cool. Did you use your eyeballs? Yeah. Yeah, you did. This is super critical. And like, I think we always skip over this, which is why I really want to like to call this piece out, is that in fact, I'm guessing you did use your eyeballs. Like you were looking at your screen, either in full screen mode or in the small mode, and you were perceiving patterns, and there's change in those patterns. And in some way, you were using the change in those patterns to make decisions. So like, this is another really critical bit. How do you think you engaged with the patterns that you were seeing with your eyes?
I think when I saw like some certain patterns that kind of encouraged me that I was on the right track. So for example, when I saw the color change to green while it's switching through the like tools, then when I saw that change to green, then I'm like, oh, that means that must be the right tool for this task I'm doing. So I think those patterns helped me like kind of figure out what sort of tools and just whether I was on the right path when going through this.
Cool. Okay, awesome. So I'm going to leave that one again, in acknowledging the time we have together. I'm going to leave that particular aspect, and we'll come back to it. Then what did you like, if you had to characterize how you stored or recorded or retained the patterns in the world that you'd come to appreciate? Like, tell me a little bit about how you began to form an understanding of the patterns that you were finding in the world, or the relationship between your actions and those observations we just discussed.
Maybe because those patterns like also occur in like everyday life in terms of like the colors that were picked. Like for example, green goes with like a green light, and it means that you're doing something good. And like so it like intuitively like allowed us to like understand that was like the right thing, and then like red was like the wrong thing if it didn't work. So I think that helped a lot.
Awesome. Okay, cool. This is really neat. And I'm going to dwell on it for a second and ask you a follow-up question, which is that imagine that you're a learning machine and you're dropped into the same environment without that experience in daily life. So first part of that question, would you still be able to leverage that convention? And two, what other conventions do you think are in this environment that you are using very naturally to navigate and to make change in the environment, but that a machine might not readily have access to, or might have to learn from scratch?
I think even like the shape of the tool. So like we understood that like a hammer obviously would not be used to like pick up something. Like we knew that it would have to break the item down. So like we would not be spending much time like trying to break it with like the tongs. And I think that that's something like a machine would have to learn, is that like tongs are used to pick up something and like hammers are used to break something. So like I think that's also maybe something it has to learn.
Cool. And there's precursors. This is really exciting. I'm glad we're dwelling on this, because there are precursors to that as well. The fact that there's cohesion or structure between the visual elements of a scene, the fact that up is up and down is down, the fact that you might expect that like you would not be able to move through solid objects, or that you were surprised when you could drop your block through a solid object, like that was not something you would expect. But if you came in naive, if you were a machine faced with this data stream, you wouldn't have any of those a priori expectations if you were truly facing this data stream for the first time. And so those are patterns you'd have to learn. Okay, we're gonna focus on one more piece of this puzzle. We've almost hit all the bits that I wanted to hit on, and then we'll talk about them in very concrete terms. But what about the motivation or the goals? So you like, let's think very specifically about a machine engaging with this world. How would the machine decide whether or not a decision was a good one, whether or not it should make a choice? Imagine it could make choices to press the forward button or the back button, or whether it press the space bar or not to press the space bar at a given moment. What would a machine use to make that choice? Choices are important.
I guess the ultimate goal would be to terraform the landscape using that small map. So I guess any step that takes you closer to that goal. But then within that, you'd have to have like multiple smaller goals. So like if moving forward gets you closer to a block, or pressing X gets you closer to a tool that would help you pick it up, I think that's how a machine would kind of make choices.
Cool. And this is awesome, because like now imagine I actually get to play the role of worldsmith here, and I've created the world within you create worlds. So I could say as a game designer, your objective is to terraform. That's cool. But to what degree, like that's a goal I could specify. But as you pointed out, there's lots of other sub goal, what you might call sub goals, objectives, waypoints the machine might try to aspire to or use as targets, and then use to make those decisions. So in what way, like, where do you think those, I'm gonna ask you again, where you think they come from? Like, where do those come from within the learning machine itself? Imagine a naive machine dropped in this world. What kind of goals come from within the machine, and what kind are specified in some way from the outside, or are none specified in either way? What do you think?
Yeah, that's actually a really hard question. I think you'd really have to program that into the robot. I don't think it has like an idea itself that green is good, like red is bad, and that sort of thing. So you'd really have to give it those specific instructions.
Yeah. The green red is neat too, because like, is green and red good and bad? I mean, you could think so. You're like, oh, I can't do something with this. Or is it state information? And should the machine map it to the signals of goodness or badness, or should it use it as state information? This is it's a choice on the part of the machine, and it's also a choice on the part of the designer. So, oh, what do we got here? Purple, an interesting color, which is not intuitive. Exactly. What about purple? What about purple? If it was orange, maybe you're like, oh, well, orange is between the two, but no, it's purple. Exactly that. Cool. This is neat. So one last question, and maybe JC wants to answer this one in particular, but just because you haven't had a chance to chip in yet. But what about the alignment of the machine's goals with my goals as, say, a designer of this environment, or someone who's placed the machine within the environment? Where do you see the points of alignment between the objectives of the machine and the objectives of the designer or the deployer? Are those at the level of the greens and the reds? Is it the level of like, oh wow, that island looks amazing? Is it the something more granular than that? What do you think?
I'm sorry, could you repeat that? I'm having a little trouble understanding.
Oh sure, no worries. So imagine that like I'm the designer of the world, and I say, yeah, let's terraform this world. Where is it appropriate, or where does the machine's goals and my goals line up? Is it that like I specify that the world should be terraformed? Is it that my perception of the green and the red as good and bad, let's say, line up with the machine's assignment of good and bad? Like where do the goals of the deployer or the designer line up with the goals that the machine is using, the valuations the machine is using to make decisions about whether or not to perform an action at a given time. And really there's no wrong answer. That's I'm curious your perspective.
I don't know. I think I'm confused. Like, isn't your goal like isn't it exactly the same as the machine's goal? Like, because you program the machine to have that goal? Like, I don't know if I'm misunderstanding it or not, but like, I don't know.
That's exactly the right observation, which is that are those things the same, and should they be? And I think in a lot of cases we do see like, let's now take, okay, this is perfect. We got to the point I wanted to get to here, which is now we can take this apart and we can think about what we've just discussed in terms of some concrete elements that I would like to put forward as the hallmarks of intelligent systems, especially machine intelligence. We have the data they use to make their choices. They have the goals that they're trying to achieve, and they have the decisions that pull those two things together. So data, decisions, and goals. Running through that pathway from data to decisions to goals, they have the elements that make that possible or enable it. One is the representation, how a machine will actually take the information from its world, structure that information into concrete elements that it can actually learn about. There's the things it stores, the information it stores, representation. You might think of this as knowledge or prediction or understanding, the patterns that are actually encoded based on that representational element. And then what we consider to be control or the ability to select actions, the way that it takes that representation and the things that's encoded, the understanding of the patterns in the world, and maps them to actions, the actual concrete things, like in your cases, the WASD or the X key or the space bar. Space bar is a great one. Like, do I press the space bar right now? Well, I'm probably going to look at the pixels, and I'm going to look at maybe some understanding of the patterns that how those pixels will change over time in the future if I were to take an action. And then that would be used to inform whether or not I press the space bar at any given moment. Do I press it now when I'm not over the anvil, or when I actually see a lot of gray shiny stuff? So that's really important. What we talked about really encapsulates that. Do you represent the world at the level of objects? Like, does the machine actually perceive trees and hills and cubes as objects, and then the distance between them? Or does the machine just see pixels? Does it just see like little flashing lights with different values? How should it be presented to the learning machine so that it can actually achieve that transition between the data it sees, the raw data, and those goals that we have for it? What goals should set for itself, and what goals should be set by the designer? Actions were interesting as well. Do we think of actions at the level of key presses? Do we think of the actions like, for you as a human, you were actually using your biomechanics and you were actually moving all those little intrinsic muscles in the hand, and there were like all those firings of all the neural architecture that supports you moving your fingers in a very elegant way to be able to control your keyboard? At what level do we think about the way that a machine specifies the actions that it can take in the world? And then again, how do we specify those goals? So these are the, like, if I have to go back to that and use this as an example, those are the key elements. We have the data, the decisions, and the goals. And then what I would call, and this is my way of breaking it down, representation, prediction or knowledge, and then control, the action space of the agent. And those are the key elements, I think. Why am I telling you all of this, and why did I spend like an hour of your time trying to help you appreciate that on maybe a deeper level? I think the reason I keep coming back to this, and when Kim invites me to come in and talk in this particular class, the reason I keep saying this sort of same message is that understanding the elements of a machine intelligence as it's deployed in the world help us think clearly about it, help us make good decisions about deployments, and help us communicate to the communities that will be engaging with that system if it was deployed in the world. I do prosthetics. So I work on like neuroprosthetic devices attached to the surface of the skin or to the bone structure of the human body that we expect to start to learn, adapt, and change. If I want to have clear conversations with users, the patients, with clinical colleagues, I have to be able to think about the machine intelligence in a way that is productive and not occluding too many things. It's not just saying, oh, well, it's AI. You put AI in an artificial limb, like that doesn't help us at all. But if we think about it, it's like, okay, what information is this system taking in? What decisions are we tasking it to make? And what goals are we hoping to achieve with it? And then how is that system representing the information? What information is it? What patterns is it trying to encode, and how does it encode those patterns? And then also, how do we think about its ability to act upon the environment? For a prosthetic limb, it might be open and close the hand or vibrate some feedback for a person wearing it. That helps us have really productive discussions. And so it's often hard to think about that. The reason I dropped you into this little video game world is because I wanted you to actually try to experience what it's like to be a machine dropped into an uncertain world and have to make choices about things like representation, have to try to maybe create your own goals to achieve what might be an arbitrarily specified task, and then decide when you might need to specify your own goals and when you can rely on goals that are specified for you by some external party. So that is like all my cards on the table. That is what I was hoping to have you think about. And then there's also one more element that I'd like you to think about, and then let's discuss a little bit, which is the when a machine should learn. In this case, I suggested that you all engage in something that might be arguably called like deployment time online continual learning. I was asking you to learn about this world while you were interacting with it for the first time. There's also a world where I would have shown you like 100 videos of someone playing this game. You would have gotten lots of prior information long before I ever dropped you into the world and asked you to begin to engage with it. There's a priori learning or sort of offline learning, and there's online learning, and there's batches, which is somewhere in between the two. And that's also very important because like, what if I changed, like, what if I showed you that like 1,000 videos of that world and someone playing that world? And then I gave you that web link, just like I did earlier today, and I'd pushed a new update. And now there was like a change to the control system. Now you had to use the mouse to control everything. And I took away your keyboard controls. What would have still worked? What wouldn't? How important is it that you actually learn while you're interacting with the world? And how important is it that you learn things before you interact with the world? A lot of you learned lots of things like, hey, cool, I know how to use a keyboard. That was really handy. You know that forward and backward matter and that you shouldn't be able to move through solid objects with your body. These are things that you've learned. I could have changed those. I could have let you clip through walls. I could have had you move in the reverse direction as usual. And so this is, I'm not saying that there's a right or wrong answer, but for any given deployment, this is also something really helpful to speak about, to think about what should be learned before a system is deployed for safety, for reliability, for explainability, for ethical implications of the deployed technology, what needs to be learned while it's deployed for those exact same reasons. And I just want to call that out, is that when a system learns and how it engages with the data stream is really, really, really important. Okay, cool. I'd love to hear your reactions now. That was sort of the reveal of what we were trying to get to. Does anyone have any immediate reactions to that?
Yeah, I just wanted to say something about the consequence of this class. I mean, you might say, oh, it's just one class and, 23 that we have. But like the day that Patrick told me about AlphaFold, during this same class, he only teaches once and, he just happened to mention it. And as you can see from, the diagram behind me, that sets so many things in motion. You can count about 100 things that I subsequently did, armed with the knowledge about AlphaFold that I certainly wouldn't have done otherwise. And so it's kind of exciting. And if you watch that video now, it took him about 30 seconds to tell me about AlphaFold, and we're off to other things. And I was like in action, man. I wrote a grant. We've now got 3 grants that sort of rely on that as an example of something that humans cannot understand, really. The folding of proteins is beyond human understanding, but was basically solved by computers in the fall of 2020. And yeah, so anyway, I'll be quiet now, but I just wanted to pipe up about the possible consequential nature of being part of this particular session in the course. Every now and then something consequential happens.
Well, I'll follow up that nature indeed. I'll share one of the new DeepMind papers from earlier this week that maybe you've seen already. It's nuclear fusion control in a tokamak reactor. Essentially, a deep reinforcement learning system that is acting 10,000 times per second to control the high energy plasma in a fusion reactor to take different shapes and forms, changing what we fundamentally know about plasma physics. So that is like maybe your new one for the day. I'll spend less than 30 seconds on it. It's a cool paper. I've been waiting to share it with people.
I've already sent that to them last night. They already have it. So
good.
I'm on top of that one. Yeah.
I think it's one of the coolest things I've seen in a while. So I like sharing it because it is very.
Yeah. Okay, let's hear the student reaction. This is all wrong if it's just me reacting to Patrick and Patrick reacting to me. The students are the important part of this. So.
For me, like this was actually super cool. I think that like kind of working through like the video game and trying it, like I like that we didn't really have a goal in the beginning, because I think that would have like, I don't know, decreased a lot of like the learning process and like figuring out what we had to do, and it was like low stakes, not like being wrong, I guess, testing out. But yeah, I really liked it. It's actually really cool, and I think that like that relies on much like machines have to learn from scratch, because we just take it for granted as like knowing how objects should technically work, and like that was kind of a cool thing. Yeah, today.
Cool. Ms. I want to react very briefly to say that one thing we didn't talk about, but is actually quite interesting, and it came up in the discussion of the green versus red versus the terraform the island goal, is that, I mean, reinforcement learning is the kind of machine intelligence I study. It's learning through trial and error. And when you get the feedback is very interesting and important. If you get constant signals of feedback, it's easy to follow. Like you can start to really sort of sculpt your flow of actions as you interact with the world. But it might reduce the flexibility or the way you explore the world. If you have a very sparse goal, like, oh, I'll give you a reward at the end of this. Like, I'll give you, if I like your island, I'll give you $5. Like, that's a very different kind of goal, because it allows you more flexibility in your exploration. So there's these trade-offs between when feedback arrives and how that impacts the freedom or the malleability of the learning system and its ability to explore alternatives. Also, it's on us as designers of systems to say, how much do I know about my domain? Do I like know if a robot arm's given a good handshake? Yes. Do I know how to make a robot arm give a good handshake? Maybe I don't, and I want to leave that as a free exploration, so the system can optimize the thing I really care about. So cool, I like that. Someone else, please.
Yeah, I really liked this presentation as well. Like it was super hands-on, and I love that. And I also really your point about how we need to consider like what intelligence needs to learn before and during as well. I never considered that before, so that was really interesting.
Awesome. And my bias is towards long-lived incremental continual learning systems. So of course I always try to throw that in, like, hey, we always train, like, we train these alpha folds and things before we deploy them, but isn't it cool that they could keep learning, that systems could actually adapt, and that's actually critical? Anyway, so I always so I'm glad that resonated.
I can hop in. I think it was interesting to see how like the goal and knowledge you had going into it kind of changed how you went about your like time in the game. Like in the first time when I tried it, I didn't know too much and I didn't have a specific goal. And then how I like played in the game was completely different than the second time. So that's not something like I feel like I've thought about much before while playing video games, but I thought that was really interesting.
It's neat because it also reflects, I know if Rich Sutton came and talked about the bitter lesson with you all before, if he's taught, has Rich came and shared the bitter lesson?
No, he's coming on the 1st of March. Yeah.
Okay.
Yeah.
I won't spoil the show then, but I will say that it's interesting to reflect exactly in your comment, to reflect back on the history of AI development. And early on, there were a lot of choices put into especially in computer vision and audio processing, like, let's do object detection. Let's assume that a chair has like a width and a height and a depth and has a location in space. There was a lot of our sort of human biases baked into how we forced machines to view the world. And as we've seen progression in technology, we've actually seen, and Rich would argue this in his commentary on the bitter lesson and learning from experience, is that we've actually started to remove some of those biases that we saw, and the end result is much more flexible and powerful learning machines. So this is neat because it's the same kind of thing. Like, how much do we bake in a priori? How much of that does it actually limit the potential of a system, and where is it required to help the system move in a fruitful direction? Neat. Nimna, what about you?
Oh man, a lot of this, I'll be honest, is going over my head. There's a lot to process. But it really got me thinking though, like a lot of the machine, like the learning it does on itself is based ultimately on the assumptions or like the information you give it at the start. So it's like, it can learn forever for sure, but like it got me thinking, like, is it kind of limited in a way by the information you give it or how you're programming it at the beginning? That might be totally wrong, but that's just like what I was kind of thinking about. Yeah.
Yep. Very cool.
Yeah, there's another kind of modeling here that's a little bit amusing to think about. So there are 25 medical students associated with the course. There's one here now. So when those other 24 medical students watch the video, it's like he's a kind of metaphor for all of them, right? So, so you may think it's not very consequential to talk to him, but he's really speaking for 25 medical students. So there.
No pressure there. You were the avatar of all your colleagues.
Right. That's right.
I'll be honest, I'm not the best representative of a usual medical student, so don't judge them too harshly off me.
No, that's fine. We're not expecting anything in particular. Yeah, well, we've got 5 more minutes, folks. What else did you could interrogate Patrick about all sorts of things.
Q&A. 5 more minutes. What questions do you want answered? I might not be able to answer them, just to be clear. But.
Yeah.
Out of curiosity, was this the first game that you've developed, or have you had like test runs of other games and then like you've modified it and like created this one, or was this like your first kind of attempt?
Oh my, well, the first games I've ever made were back, oh my goodness, well before the 2000s. And
wow.
They were very simple little ones and like basic and things. I've long loved games, but in terms of this particular game, I built everything from scratch, like I owned up to earlier, like everything from the wave shaders, like the shader graphs that make the waves, to the assets. There's a couple of trees I borrowed in some of the texture maps, but like the rocks and things like that. Those rocks are actually a rock from my wife's rock collection. I took pictures from multiple angles, made the shiny maps, made the bump maps and things for it. So like I put this one together partly as a personal development learning exercise. I started first week of January, and this is the result of a essentially a month-long sprint, mostly in the evenings in front of the fire watching Netflix. I'll be honest, but so cool. It is the first time that I've tried to go like full start to finish, everything, all the elements, building them all from scratch, and then actually deploying them in a playable form, like a publicly playable form. I've never deployed a WebGL game before, maybe some of you were having slowdowns or something. That's why I'm not. It runs incredibly smooth with a build on like Apple Silicon, but it's the WebGL was the first time I tried to deploy that. So yeah, this was a new thing for me, and I was really excited to try it out. And thanks for being patient with it, because this is, again, I've never publicly deployed a game before.
So I have a surprising, really awesome, burning question. That is that you are a poet, actually, and have held leadership roles in poetry and so on. And you do the stuff you talked about this last hour. Is there any overlap between those two? Or are they entirely separate? The poetry has nothing to do with this, and so on. What are your thoughts about that?
Well, Kim, I mean, if you have a large network and you have a bunch of inputs going to that large network, and there's lots and lots of connections, can you separate them out into pieces? Is that possible? Like, wouldn't one input influence all the other inputs in one way or another?
Yeah. No, I certainly feel, I mean, when people ask me about my life, I tell them it's one interconnected whole. You may not be able to see the cohesion, but it's there. So I guess your life is sort of similar then, right? The poetry fits in there somewhere. It's not a thing apart. All right, well, we've answered that then.
It's really important too. You know this, Kim, I've said this before, but it's super important. The level of like the diversity of perspectives of viewing the world, which is actually very on point for our topics of the day, but allow, I think, a deeper understanding of the core concepts and it allows us to be very thoughtful and deliberate with what we do without becoming too single focused on just one element of a much wider thing. So I do think it's important to keep those different perspectives, and the artistic perspective brought into the realm of science and technology is absolutely critical. If we don't have that, I think that we are limiting our potential as a industry, as an academic body, and also as a species. So yeah, no, it's super important. Thumbs up.
Cool. All right. Okay, well, we're in our last minute of the session. I have a feeling you might remember this session. It'll be in 2 parts, and then there'll be a part that's not recorded where my computer was crashed. So for that, you had to be here. So you could sort of try to fill in the gap between part 1 and part 2 with your own experience, eh? So.
No, Kim, I disclosed to everyone here that I've spent almost a decade trying to dodge your cameras. You know that in my physical lectures, I stand just to the side so the camera has to keep tracking me. And I finally found a way to actually have a part of this lecture that wasn't recorded. And I will cherish that always.
You did, yep. So Patrick spent one of the face-to-face teaching sessions. You can probably imagine this. In an ordinary hardback chair, he sat on the back of the chair, and the whole hour, it looked like he was going to fall on his whatever, but he never did. He sort of balancing on the back of the chair the whole teaching session. There were other sessions where he took the students out in the hall and marched them this way and that, and had them do all sorts of cool stuff, measuring stuff that they never thought of measuring before. Yeah. So you can probably imagine those things, having witnessed this session today. So Patrick, thank you very much once again for a superb teaching session, and we'll see you next time.
Bye, everyone. Thank you so much for participating, and thanks for trying out something new and wild and wacky. I had a great time with you all today, and thank you for having me. Have a good rest of your afternoon.
Bye-bye. Yeah.
Thank you.